Hello, we are going to discuss an end-to-end project of coupon acceptance prediction, and if you would want this particular collab notebook, the link is in the description. So let's dive into this problem. This is a coupon acceptance prediction which predicts how likely is the user to accept the coupon while they are driving. And so here we capture the driving context, like the driving behavior of the person, to where is the person heading to, with whom is the person traveling, what kind of coupon is given, how likely is the person to visit this particular restaurant, what is the time with the weather conditions, what are the details of the coupon. So all these the parameters are captured, and then we predict how likely is the person to accept the coupon. So let us see the data. These are the imports and this is the data. Now here the data includes 25 columns. Let's look into the data. So there is destination, indicating where is the person heading to, passenger, with whom is the person traveling, weather, this can be rainy, snowy, sunny, temperature, coupon indicates what kind of coupon it is, expiration can be 1 day or 2 hours, gender, age of the person, marital status, has children or not, the education, occupation, income, car, whether the person is traveling by car, coffee house, or is the person going to prefer carry away, for how many times do they do carry away. Then restaurant less than 20 indicates the restaurant which requires less than $20 of spending. Then restaurant 20 to 50 indicates the restaurants which need $20 to $50 of spending. Then there is 2 coupon, GEQ 5 minutes. GEQ indicates greater than or equal to. So now GEQ 5 minutes indicates is the destination at least 5 minutes away to use the coupon. GEQ 15 minutes means is the destination at least 15 minutes away. So here we are analyzing how is the distance affecting the coupon acceptance and how likely are the users to accept coupons with shorter travel times. So this is what this GEQ indicates, and this direction same, is the person traveling in the same direction as the coupon, or is he traveling in a opposite direction. And these two variables are inverse of each other. So we will see how we check this with the help of correlation and remove any one of these variables. This is the Y variable, whether the person accepted the coupon or not. So this is df.head. Now once we drop the duplicate records, we get 12393 records with 25 columns. There are 7012 records for accepting and 5381 records of not accepting, indicating that the data is balanced. The null values are more, as we can see, in car, and then if it is coffee house, restaurant 20 to 50, carry away, restaurant less than 20, and bar. So these have some number of null values, but a lot of null values are seen in car, and so we go ahead dropping this particular column. For other values, for other columns, we see that there is coffee house, then there is restaurant 20 to 50, carry away, restaurant less than 20, and bar. Now as we can see, this particular data is categorical data, and the categorical data has to be filled in using mode. So here we fill the null values using mode, and we also rename this particular Y column as accept. Okay. Now we have 393 records with null values. We check for the outliers using z-scores. So here we calculate the standard deviation for the column. We calculate the z-score. If the z-score is lying more than 3 or less than -3, that is if it is beyond modulus of 3, then we print the outliers. Now outliers are checked for numerical values, and so we do that. No outliers are detected, and we check for the unique number of values for each of the column. And as we can see here, GEQ does not show any variability. It's constant for all columns, and we look for variability in our columns, and so this is not at all helpful for us. So we go ahead dropping GEQ. Moreover, here age is 21, 26, 31, 36, 41, 46, 50 plus below 21. Now these 21, 26 can be put in one category. See, more the number of categories we have, and if we have to apply one hot encoding on it, then it will lead to lot many categories. So here we try to shrink on the categories by combining 21 and 26 as 21 to 30, 31 and 36 as 31 to 40. So this is the code that will help us to bin our data. We have education, these various degrees, and occupation is also there. Then income, as we can see, again this is put in categories, and this can be for this particular data, ordinal encoding can be done, where a lesser value like 12,500 to 25k can be 0, and 2,500 to 37499 can be number 1. Then 37500 to 4999 can be number 2. $50,000 here, this can be 3, and so on. Now Matplotlib shows that though there are some data with numerical values, we see a lot. So though there may be numeric, like has children has 0 and 1, temperature has certain values, but still these are more or less categorical data. So though there are some numeric features, there are only 2 or 3 values which can, so that so all these numerical variables can be considered as categorical data itself. So here we change all the columns to object type, and then we do EDA. Is in EDA, the strategy that is used here is we perform cross tab on a particular column, let's say a destination, and we check how likely is the user to accept the coupon. See, we see that coupon acceptance is more in the case of no urgent place. Here this is almost an equal distribution. Here again it is almost an equal distribution, but the person is likely to accept the coupon when they are traveling to no urgent place. Similarly, when it comes to temperature also, here we see a stark difference indicating that the person is likely to accept when the temperature is hotter, when the weather is hotter, temperature is higher, which is again indicated in the case of weather also. See, here we see the person is more likely to accept in the case of sunny weather. By passenger, again here we see the double difference of a double, indicating the person is likely to accept when they are traveling with friends. So this is how this EDA is helping us in understanding about the data. And if we have to assess, see, carry out and take away, restaurant less than 20 has higher acceptance rate. Education, there is not much of inference that can be seen. In case of has children, here this is better, that is the person is likely to accept when they do not have children. This is the distribution of the various coupon types. These are the various 5 types of coupon, and this is the plot between temperature and the GEQs. This chart, pie chart, shows the gender distribution. Then there is age distribution by coupon acceptance. Now let us move on to feature encoding. Because no numerical variables are there, no scaling needs to be done. One hot encoding will be used for few, and label encoding, that's the ordinal encoding, will be done for other columns. So now let us see for what columns are we going to do what kind of mapping. So now bar indicates how many times is the person visiting. So here never, less than 1, 1 2 3 4 to 8, and more than 8. These are the 4 values, and these are put as 0 1 2 3 4 depending upon their frequency. And this mapping can be used for bar, for coffee house, for carry away, for restaurant 20 to 50, and for restaurant less than 20. For the age, another kind of mapping is used, similarly for temperature and also for weather. No, sorry, not for weather, but for mapping the income, for education also. For these, ordinal encoding has been done. One hot encoding has been done for destination, passenger, weather, coupon, expiration, gender, marital status, and occupation. For all these, one hot encoding has been applied. So these are the 12393 records. From correlation, we understand that there is only, we calculate the correlation and we filter to keep only the correlation which are more than 0.7 or less than minus 0.7. And so here we get only direction and same and direction opposite to be having a -1 correlation, which absolutely makes sense, because when this is 0, this has to be 1. And so we drop one of the columns, and then next is to analyze multicollinearity. To analyze multicollinearity, if the multicollinearity is found to be more than 5, that particular column needs to be dropped. And so after dropping those columns, we are having 43 columns in general. So now we are having 43 columns and dimensionality reduction is needed. So we are going to use various models and also make use of RFE here as the technique. RFE is recursive feature elimination. So from the available features that are there, the model will choose the best n features and it will give us the result. So here we make use of RFE. LDA is mostly used for multi-class classification. TSNA is used for image processing and NLP. We also have methods like forward selection and backward elimination. So these methods can also be used. PCA distorts the set of features and it creates the new features, and so we are not going for PCA because we should know what is the ascertaining feature that is helping us to decide our outcome. And so here for this particular reason we use RFE here. So we split the data into Y and X. For our for our purpose, we just initially make use of 1000 records, though we can run the entire data set also. So initially we have the logistic regression, and then logistic regression is giving us the accuracy as 0.705. Now this logistic regression, when it is combined with RFE, RFE here is applied on the model, and we want 30 features to get selected, and then once it selects, see, these are the feature rankings, and these are finally the first 30 features that get selected, and with that we are having the accuracy of 0.7. Then next, decision tree model is applied. So how it works is we apply various models. We apply various models with RFE. Whichever is giving us the best accuracy, on that we apply hyperparameter tuning. So now we apply decision trees. Decision tree gives us an accuracy of 0.71, whereas random forest classifier gives us an accuracy of 0.77. Now, because till now 0.77 is the best accuracy so far, we go ahead applying hyperparameter tuning and RFE here. So for we use RFE, and on that we apply hyperparameter tuning. So we use 50, 100 or 150 trees, depth as none, 10, 20, 30, and the max features as auto, square root or log 2. And then the best parameters that were obtained were max depth as 10, max features as square root, and a number of trees as 100, and that gave us the good accuracy of 80.5% as seen over here. So this is random forest score with 80.5%. Now SVM can also be the next is SVM applied. So now SVM gave us the accuracy of 0.74. The next was CatBoost. Now these are boosting algorithms. So here in boosting algorithms, here CatBoost was applied, and CatBoost gave us the accuracy of 0.765. Then XGBoost was also applied, and XGBoost gave us the accuracy of 0.785, which is a good accuracy. So on XGBoost with RFE, 0.77 was the accuracy, and XGBoost with RFE and hyperparameter tuning, we got the accuracy same as 0.785. So till now, random forest with hyperparameter tuning has given us the good accuracy. Apart from XGBoost and CatBoost, here we apply bagging techniques also. Now bagging technique here is specified as estimator as the base estimator. The number of base estimators to be used is 50. Max features is 0.8, that is the fraction of samples to draw from X to train each base estimator is 0.8. Then max features, max samples is 0.8, max features is also 0.8. That is the fraction of features that are to be taken from the training data set to train each of the base estimator. So that gives an accuracy of 0.795. So now, because this has given us a good accuracy, very similar to random forest, we go ahead applying hyperparameter tuning onto this, and that has given an accuracy of 0.79. The next is stacking classifier. Now in stacking classifier, see, we have in stacking classifier, we have the base models. So we have random forest classifier, XGBoost classifier, decision tree classifier, and bagging classifier. Now there is a meta classifier that gets used along with that, and that is logistic regression. All these models are put under stacking classifier. The stacking classifier model is built, and that has given us the accuracy of 0.79. So it's almost like the stacking classifier and the bagging classifier and the random forest. These are the models which have given us good accuracy. Here what can be done here is ROC AUC score and the F1 score can also be checked. Here precision and recall are the two measures. Precision will indicate of all the people who were likely to accept, how many could my model identify. That will be recall. Now precision here will indicate of how many predicted positives, that is the model had predicted to be positive, how many actually accepted. So that will be precision. Precision indicates how many of predicted positive was predicted positive, how many actually went ahead and they were actually correct. But recall will indicate of the total number of people who were likely to accept, how many could my model identify and how many were missed. So precision and recall are two important measures. So a trade-off between the two is required. For that, F1 score will help us combine the two measures. So if we are looking for, so now this depends upon the business model. So if we want to maximize the precision, or if we want to maximize the recall, or if we want a combination of both, then F1 score can be used. The link to this particular notebook is in the comments. Thank you.